Yes, in the end of this session, you will need them. Yes. Okay.
You mainly need them for running Python in batch mode, but you can clone them to your home directory or something like this,
Yeah.
or just download that specific exercise you need.
Yeah.
Okay, I'm going to start talking now so that we don't get too late. Load and run Python and use packages. At these centers here, UPPMAX, HPC2N, LUNARC, and NSC, and indeed most other Swedish HPC centers, and most centers elsewhere as well, we call the applications available via the module system modules. And here are links to more documentation on modules for each of the 4 centers that we have in this course. There is a short cheat sheet here for how to use the module system, and these are the most important commands. You will rarely need any others. Module spider will be used to tell you which modules exist. You can see here, it will give you a very long list of everything installed. It can always be shortened ML module, so ML spider instead. You exit this long list with a Q if you don't want to look at all of them. If you want to check for a particular software, you would say module spider Python, for instance, or whatever the name of the software you're interested in. And then it lists the ones that are available at this system and some information. If you want to see how you load a specific module, you write module or ML spider, and then let's go with this one here just randomly. It tells you in order to load it, you should load this here and then Python. Since many of the other modules you will need today will need the full GCC and not just core, load GCC 12.3.0 instead of GCC core. There is never harm in loading that instead. It simply contains more stuff than just the core of it. If you want to see what depends on what is currently loaded, you use module avail or MLAV. At some centers, this will give you most what is in module spider, for instance, UPPMAX. At HPC2N, you only see what you can load directly, and it changes after you load, for instance, GCC. It is the same at Tetralit and at Cosmos. So let's load this Python here. So I'm loading GCC and 12.3.0. And now I will do ML avail. And now I should be able to see that I can load Python and in which version. It should be listed here somewhere. Yeah, there's Python here. Okay. So I will load Python. I can say ML or I can say module load. And then this Python here. I can do ML or module list to see what I have loaded. I can unload a module with ML or module unload or just a minus the version that of an software I just loaded. And now it's gone. I can also remove all of them with module purge or ML purge. And then I only keep the so-called sticky modules, system default modules, and some environmental modules. At UPPMAX, MLAV should give you all of it. At Tetralit, it would be ML Spider. It scrolled pretty fast, but it was all of it. It just didn't break in between. So I guess you would have to use less or something. Pipe it to that. So I will see how do I load Python, which Pythons are there. This is tetralit. It lists them here. And I'm going to randomly pick this one and see how do I load it. Again, there are prerequisites. Pick one full line of them. So I could take this one. And I'm going to do like this. I am again doing the whole GCC one. And then I am loading Python 3.11.5. And they are now listed here. At UPPMAX, let's see what Python is there. The difference with UPPMAX to the others is Python is written with lowercase. So you can see here, these are the ones available. So let's go grab Python 3.11.8 there. And it's loaded. And also UPPMAX environment variables is loaded. Okay. So this was a quick walkthrough of modules. And you should test these out now here when we, well, what I'm doing here is more or less what I already did. But so here is a repeat of, you can see everything of it with ML avail at UPPMAX. At NSC, apparently also everything is available with both ML avail and with ML spider. ASP.C2N and LUNARC ones are hidden until you have loaded the prerequisite. But you need a prerequisite at NSC as well to load it. You should, for reproducibility reasons, always load a specific version of a module instead of just the default one. Because when we do install a newer one at the centers, the default one may and will change. So, and some things may not work the same for you then. You should always load a specific one. Many modules have prerequisites at ASP.C2N, LUNARC, NSC, and that is also the case for the Python modules. And yes, you saw, as I just did, do module spider, the module, and the slash the version to get a list of what you need to load specifically. And let's all try and do this. So if you're not already logged in, do so. And for this example, you don't need to go to this storage directory or your other directory where you created your ASP.C Python material, where you cloned it, but you can, it doesn't matter. Right now, we are just testing modules. So if you're at UPPMAX, do module avail Python to see which versions are available. At ASP.C2N, do module spider Python. And remember, capital P, lowercase p. LUNARC and NSC, same as ASP.C2N. So you can see the output here, but just try and do it yourself. It should take 1 minute or less if you are logged in. And yes, we recommend Python 3.11 some version in this course for all of the centers. There are a small number of examples at NSC. We'll use Python 3.10.4 because more packages are installed for that, but the packages are being installed for 3.11 there as well. So we will use that for most of it. Okay, I'm assuming that you managed to see the Python modules, the Python versions. And now let's try to load the Python module just like I just did here. So you saw which Python modules were available, and then try load 3.11.8 at UPPMAX. 3.11.3 at ASP.C2N, 3.11.5 at LUNARC, and 3.11.5 at NSC. And you can either go back and do module spider python / the version, and then be told what prerequisites it has, or you can copy this, but I think you should try find it yourself. But these are the prerequisites listed here. So load that. So load prerequisites where they are needed, and then load the module. Prerequisites also need to be the right version, of course, as you saw in my example. There will be system installed Pythons at all the centers. Don't use it. Always use the Python module. The system installed Python is usually old, and there will be no packages or modules installed with it. So don't use that. Always load a module. And yeah, why are there both Python 2 and 3? There are existing software that needs Python 2, and that's why we still have it. Some will use Python 2, some will use Python 3. But yeah, you use the one you need. In this course, we use Python 3. So I'm just going to go past this here. It's just specifics about these modules, Python 2 and 3 at the centers. You can read it, but it's not important other than, well, use the one you know you need. Okay, so if you want to run your Python script, of course, you may have edited on your own machine and transferred it to the HPC center, or maybe you were editing it at the center. And if you don't already have an editor that you want to use, then these are some suggestions. The thing is that, as you know, it's Linux running on all the centers. The notepad and things like this you may be used to from Windows or whatever editor you have used on whatever OS. You will have to use the ones that are on Linux. And if you're just logged in with a terminal, as I am, you would use, for instance, something like Nano. Nano is a simple editor, and it looks like this when you open it. So if you just type Nano and open it, it looks like this. You type something, and then you want to save it. You hold down Control. This hat here means you hold Control down while you type X for exit. It will then say, do you want to save your modified buffer? If you say no, it just ignores what you wrote. If you say yes, then it asks what file name do you want to use if you did not open it with a file name. And now I just say my file text. And then I click enter. So you could say nano my Python py, and then if you wrote something, yeah, it's not a Python program. I just write something here. Control X. Now, do you save it? Yes. And then it uses the name you suggested. You can still change it, but it will automatically suggest the one you opened it with. And then press enter, and it saves it. You see, both of the files I just made are here. If you are using a graphical interface like ThinLink, which you may, or on demand or something, then gedit is good. And it requires you have connected with ThinLink or with SSH minus X or minus Y. I have done that, but it is most likely slow because I'm running a regular SSH link, but it came up here, as you can see. And this is the editor we suggest if you have a graphical interface. And you can create files here by clicking this, or open files with here. Or you could just have written gedit and the name of the file you want, and then you save it by clicking here. And also you can search in it and things, but yeah, it's slow because I have a slow connection to it. You will see that when we are editing things, I will just break out of this. We may use VI or Vim. It is simply because it is somewhat more powerful than Nano. You can do more things with it, but it's also a bit unfriendly. If you're using Vim and get stuck in it, press Escape and then :Q, and this exclamation mark should actually have been included, because that means exit and don't save. So if you open something with VI my new file.txt, I press I first. You can see when you just open it, it just looks like this. You cannot enter anything unless you hit one of the characters that makes you able to hit it to insert things. But I will give you the editing mode or the insertion mode. So I type something, and to save it, you need to press Escape in order to go to command mode. And then you can type a colon and W for write and Q for quit. If you don't want to save it, you just put colon Q exclamation mark. It will exit and not save anything. But now I will save it. And it exits. But use Nano and gedit if you don't know the other editors. There is also Emacs, which also is best for graphical user interfaces, but can be used on a regular terminal. Okay, so let's try do this. Let's try open a script, and we call it example.py, and just open it with Nano. So try do that, and then insert this text, save and exit, and then, oh, I'm just wondering what was here. Okay, we will just test it here, and then you will run it in Python. So let's see, I will do it now on Tetralit. So I will say nano example py. And now I have a new file here. I'm going to make this a little bit bigger. And then I will just copy this text here over here. And when I have done that, I will save and exit. I will hold Control down. And I guess Control O also works, or Control X. You can use either of them. But the file name to write is, as you used before, example.py. That was the one you opened it with. That is the one it suggests. We saved it. We can now exit it. It's already saved. But if you just do Control X, it will ask you to save it. We now have this file here. It is example.py. And I'm going to try and run it with Python. Like this. And it ran. Hello world. You could also say Python 3, because Python is a soft link to Python 3 when you have loaded Python 3 versions.
Yeah. May I interrupt and call for a break? And
Yes,
we can
let's do
continue
that.
afterwards. So
Yeah.
let's convene at 10:25.
Yeah, I was just testing, but I can go there now. So I will clone this. And now I have it also on Cosmos. Great, it works now. But let's continue. So now when we tried running a script, I'm going to remind you of one thing, which is only run very short stuff on the command line. Otherwise, you have to use the batch system. And we will talk more about that later. But all the things we are running here right now in this section, it's very short. You can run it on the command line with no problems. Okay. So let's talk about interactive Python shells. You can start the regular Python by simply saying Python. And then you enter the Python shell. And you can do things like A equals 3, B equals 5, C 4, D equals A plus B plus C, and then D, like this. So it works as you would expect. And you can exit it by either pushing, holding down the control and typing D, or you can say quit with parentheses or exit with parentheses. All of it works. And if you want more interactiveness, you can run IPython or Jupyter or others, which uses IPython, I guess. But for now, just know that you started with IPython, but you also need to load IPython at the other centers. At UPPMAX, you can just use it because IPython is loaded together with regular Python. If you're at HPC2N, you need to load IPython. Same for LUNARC and same for Tetralit. But I think we don't need to test this now because we're not going to really use that in the course otherwise. Okay, so let's go to packages instead. And we will call them Python packages, not Python modules, because then there will be confusion with modules on the system. And there are a ton of Python packages. That means you can do almost anything. There are also being made new packages. So it's worth checking out. Has someone else done what you are going to do? So you can just import a package that does it instead of having to write extra code. And it can help a lot. So you only need to write a little bit and then you can use packages for most of it. Many scientific tools are distributed as Python packages. And that means you can just run a script in the prompt and define the files to be analyzed and the arguments that define what you want it to do instead of writing a long program for it. So that's often nice. And on this Python for Scientific Computing course that they had on Aalto University, there is a very nice introduction to packages that you can go and read later if you want to. So you might say, how do I find these packages and which versions are available? And what do I do if I need other packages? Of course, what are the differences between these centers and the other centers also? So we'll look here at how to check for packages and how to install your own packages on the different clusters. And first, how do I check for packages? In general, you do module spider and then the tool name or part of the tool name and check to see if you can find it that way. So maybe you're at the HPC2N and you say module spider and you want to know, is TensorFlow here? And then it tells you in order to use TensorFlow, you need to load this module, for instance. And then you would need to repeat module spider, but then on one of the versions. Say you're interested in this that is CUDA aware, which is also nice. And it tells you you need to load this here, and you also need to load this one. So I'm going to purge what I already have and show you that you do module load or ML on these two. And then I will also take the TensorFlow module. So I have the prerequisites and the module. And it takes a little while. It's loaded. And now do module list or ML. And then I can see what got loaded here. And you can see it loaded a ton of things, including CUDA and Python was loaded automatically. And also something called SciPy bundle was loaded, which contains things like NumPy and pandas. MPI for Pi was loaded as well. So many things were loaded here with this. So that's good. You get many things that way. And in general, many of these modules load other things, and you can always see what with the module list afterwards. So if you want to check, you can also on UPPMAX do module help Python version. But on Python, on HPC2N, LUNARC, and NSC, you use module spider, or you can write it like this, because then with this regular expression, it checks for anything that contains Python. But beware, you will get a lot of output. It will not just be Python packages. There will also be programs that are compiled with Python, so check it carefully. So now when you have
Brigitte, can
loaded
I
stuff,
ask something quick?
yes.
You mentioned that something that how do we know about which modules are loaded? Is it ML avail or?
If you want to see which packages you already have loaded, use module list or short ML. So you type module list or just ML, which is a shortened version of module list. And then it lists everything you have loaded. Okay, so now when you have loaded something, you maybe want to see which packages are now available. And you can always do pip list to see which packages are there. And it will be a lot of things if you have loaded many modules. You can see here there is a lot of packages here. And it also tells you the versions. If you want to see which ones you have installed, you can do pip list -- users. And if you have it in a virtual environment, you have to do it inside there. But we'll talk more about virtual environments in a moment. You can also test from inside of Python to see if a package is not already installed, or if it's installed, I will say import NumPy. And it worked, so that means that NumPy is available. Okay. And if it's not there, you can use pip, or at some centers also conda. Not at HPC2N though. If you want to check the path to the package you're using, you can import the module and then print this here. So I could say print, and it was NumPy. And then underscore file there. And it got unhappy, so I probably forgot something. I did. I needed 2 of these, I think. Yeah. And then you get actually the whole path to where it's installed. If it's something that's installed in the system, you probably don't need this. But if it's your own own package you have installed, then maybe you want to see where that is located, and then it might be worth it. Okay, so take a few minutes, just go to the center you are logged into, and see if these packages are installed. Use 3.11.8 on Rackham, 3.11.3 on Kebnekaise, 3.11.5 on Cosmos, and in this case 3.10.4 on Tetralit. So if you already have something loaded, do module purge, then do module load Python/3.11.8 on UPPMAX. On the others, check the prerequisites, load those, and then load the Python module. Then do pip list and see if these are available. The solution is here, but try it out yourself also. But let's just take 3 minutes and try that. Okay, I hope you got this to work. Otherwise, there will be more exercises later. This is maybe not the most important one, but it's nice to use to see how you find these modules and see which ones are installed. Okay. So again, the solution is here if you didn't find it, but I'm guessing you did. So remember, at HPC2N, LUNARC, and NSC, you usually need prerequisites for the Python module, and you also need to load Python extra modules in order module bundles before you can use the packages, because very few are installed with just Python. And there are some of these listed here. And you can find more with module spider and -r, and then this reg expression that was listed above. But on UPPMAX, most of the packages are in Python. A lot more are in Python_ml_packages, and you add -CPU or -GPU depending on which type you are running on. If you're running on CPUs or if you're running on GPUs. And there are also some packages in this here. And there is a bioinfo tools package also, a module also. At HPC2N, there is also many modules, many more, because there is not a lot installed with Python. But the SciPy bundle is often a very useful one. It contains NumPy and Pandas and SciPy, and also MPI for Pi. And so those are good if you need those. And there's Matplotlib, there's scikit-learn, there's TensorFlow and things like this, and Jupyter Lab, so PyTorch. Many of these needs to be loaded as separate modules. And the same is the case at LUNARC and also at Tetralit. Okay, so I will just go through this demo or type along. And when we have done that, we will, I don't know, we have already had a break, so maybe we should continue directly to virtual environments and installing packages after that. But here we will load, run, and use aside installed packages. And we will return to this example under the batch session and run it again, but that time as a batch job. There's also follow-up exercises for extended versions. I'm not going to look at that now, but you can look at it later if you want to try more exercises. We will use pandas and matplotlib in this very simple example, but not talk about them. It's just an example. Later in the course, there will be a lot more about pandas and matplotlib. So there is a data file with this name, Scottish Hills CSV. It's found in the directory under HPC Python exercises examples program. And this will open a plot, so you need to log in with ThinLink or have X11 running on your system. And I found an example at this place that I modified a little bit, and that is what we're using here. On HPC2N, on LUNARC, and on NSC, you need to load tkinter in order to use a backend for matplotlib. It seems that in some later examples, you will also need to do that on UPPMAX and use a different backend there, but that will be mentioned when you come to it and when you need it. So for this example, you will load these modules here and including tkinter for HPC2N, for LUNARC, and for NSC. For UPPMAX, it will be enough to just load Python 3.11.8. It will contain all we need here. And for HPC2N, you will load this. LUNARC, very similar, just a different version. NSC will also load modules closely the same, but different modules, different versions, sorry. Okay, I am going to first do the example here on HPC2N, and now let's do it on Tetralit, because that is what many people will be using today. So I will first say ML. I will see I have a lot of stuff loaded. I will purge it. And then I will go and copy this link here. You can also use this here. So let's paste it and load all of it. You can see here we are running with Python 3.10.4, or actually it's not listing that, but we are. Let's do ML. So we can see that it loaded Python 3.10.4 as well. It gets loaded together with the SciPy bundle. Here, this one. Okay, so now when we have loaded the modules we need, if you are on UPPMAX, you only need to load Python 3.11.8. Okay, and we want to go to the exercises directory. We want to go to examples. We want to go to programs. And let's see what's in there. We have this data file, the Scottish Hills. And that is what we will need now. So with all this loaded, I will start Python. And then I will scroll down to the example here. So if you are at HPC2N, LUNARC, or NSC, you will first have to load matplotlib and set the backend. So let's do that here. Then on all systems, do this here. You import pandas, matplotlib pyplot. This is just an example. It's not, you don't need to know what happens here. I managed to copy too much. I will quit it in order to make sure that it didn't do stupid stuff with a blank character, which it may. So I'll just repeat this. And then I will again copy from here. Then we are creating the plot. It takes some short time. And then let's see the plot. And it's this one. And I'm going to hope that you actually see it and that Zoom doesn't do something weird. But I got a plot popped up here and you could then save it or whatever. So this works. And you can run the same example in all the other centers. The thing here is, of course, well, what if you ran it as a batch job? Because the batch job is not interactive, and that means that the plot will not be shown. Well, then you will just save it as a picture instead. And we will look at that when we get to run this example in the Python in batch. So. And if you did that, there are programs you can use to look at the image files. There's EOG at most of the centers, but on HPC2N it's called EOM instead. I'm not going to talk much about this more. I mean, this exists as a Python script as well, and you could just put this to a file and then run it with Python instead. And I don't want to do the exercises because we are out of time, but these exercises are just continuations of this same example here. This script here. I'm just going to exit Python. Like this. I was in that here. And it should be here. Let's see. Pandas. This one you could use. And run that. You will just run that with Python. And then it creates an image file. And you could look at that. So, okay. I am going to stop sharing. And